Hello everyone. Today I'll be going through AMATS chapter 7.2 from this particular AMATS textbook. Okay, so let's start off with question 1. So given that the lines x plus 2y minus 2 equals to 0 and y minus kx plus 4 equals to 0 are perpendicular, right? Find the value of constant k. Okay, so first thing first, because they are perpendicular, right? So we are going to make use of the relationship gradient, right, of L1 times gradient of L2 equals to -1, right? So let's say we have something like that. Okay, so this is L1 and then this is L2. Okay, so when we take these two gradient and multiply them with each other, right, we will get -1. Okay, so basically for the first step, right, what we are going to do is I'm going to label this as L1. Yeah, I'm going to label this as L2. Okay, so L1 is x plus 2y minus 2 equals to 0. And then L2 is y minus kx plus 4 equals to 0. Okay, so I'm going to change these two line equation to fit into this y equals to mx plus c form, right? This equation form. So 2y equals to negative x plus 2. Y equals to negative half x plus 1. So what I did was I just divide every term by 2. Okay, so that's what I got. And then for L2, right, so same thing, change it to y equals to mx plus c format. So y equals to kx minus 4. Okay, then we are done. Right, since okay, so just now we discussed, right, since that these two lines are perpendicular, meaning to say, right, negative half times k is equals to -1. Okay, so negative half, this is from L1, k is from L2, right? The gradient of L2, the gradient of L1, right? So how do we find k? So k equals to -1 divided by negative half, which will give us the answer 2. Okay, so our k value of the constant k is 2. Okay, that's for question 1. Okay, let's go through question 2. So question 2 says the line y equals to ax plus b passes through 1, -2 and is perpendicular to the line y minus 3x equals to 4. So find the value of a and of b. So basically what we are going to do is we're just going to draw some sketch lah. Okay, so it will look like this. So let's say this is y minus 3x equals to 4. Okay, I'm just going to label this as L1. All right, and then I have a line, probably something like that. Okay, ignore, I mean, it's not straight line, but because I'm not using a ruler. So let this be L2, which is y equals to ax plus b. Okay, then they say that this two line is perpendicular. All right, and then this L2 line, right, also cut through this point. Okay, 1, -2. Okay, it's just a random point that I just draw along the line. Okay, I do not know where it is, but I know for sure this line cuts through this point. Okay, as per the question. Okay, so what do we do? First step, right, we need to realize that these two lines are perpendicular, right? So same concept. M gradient of L1 times gradient of L2 is -1. Okay, so from this, from equation L1, right, we shift minus 3x to the right. So y equals to 3x plus 4. Okay, and then L2 can remain because this is in the form of y equals to mx plus c. So as you can see, right, m of L1 is 3, right? Gradient of L1 is 3. And the gradient of L2 is a. Okay, so that means basically we have 3 times a equals to -1, right? So a is equals to -1 divided by 3, which is -1/3. Okay, so a is -1/3. Okay, so we have found the value of a. So what about value of b? So basically we need to sub in our a value, right? So such that now our L2 is actually y equals to -1/3 x plus b. Right? So how do we find b? Okay, we need to sub this known coordinate into this equation. So sub x equals to 1 and y equals to -2 into equation. Okay, so after this, we will have -2 equals to -1/3 multiplied by 1, right? Plus b. So my b is actually -5/3, right? -5/3, right? So therefore, my L2 equation, right, is y equals to -1/3 x minus 5/3. All right, and then my A is -1/3 and my B is -5/3. B is also so-called the y-intercept. All right, y-intercept for L2. Okay, in this question. Okay, can. So that's it for question 2. Go through question 3 together. Question 3 is quite similar to question 2. All right, so let's start. So find the equation of the straight line, okay, which passes through 4, 5, and this straight line is also perpendicular to the line 2y equals to 4 minus x. So let's draw a diagram again. So let the diagram be something like that. So this is 2y equals to 4 minus x, all right, and then let this be L1, okay, L1, all right, and then the line that is perpendicular, okay, let me just shift this a bit more. Yeah, okay. So a line that is perpendicular, so probably something like that. Okay, so this is the straight line that we want, right? This is our L2. Okay, they want this equation. They want this equation. Okay, L2. And then this line also passes through the point 4, 5. So let's just label 4, 5. Okay, 4, 5. Right. So first step first. Okay, we need to readjust L1, right? To what? To find out what is our gradient. Okay, so we need to find out what is the gradient. Okay, so what do we do? Just divide 2 to all the terms because we want y equals to mx plus c, right? So y equals to -half x plus 2. Okay, so basically all the terms here I divide by 2 lah. Okay, and including this. Okay, so that's how I get -half x plus 2. Okay, so the gradient of L1 will just be -half. Okay, so if the gradient of L1 is -half, so gradient of L2 is equals to -1 divided by -half. Okay, which will give us 2. Okay, how come? Because gradient of L1 times gradient of L2 is -1, right? Remember this? Right? So we have -half times ML2, gradient of L2 equals to -1. Right? So that's why it becomes like that. -1 divided by -half. All right, so gradient of L2 is actually 2. Okay, so next, so we know that L2 is actually y equals to 2x plus c, right? So we need to find out what is our y-intercept. Okay, so what do? We sub in a known point, right? This known point 4, 5. So sub x equals to 4, y equals to 5 into L2. Okay, into L2. Right? So therefore, we have 5 equals to 2 bracket 4 plus c. So c is equals to -3. Okay, so therefore, our L2 is actually y equals to 2x minus 3. Okay, so the equation of this straight line is y equals to 2x minus 3. Okay, and so that is question 3. Okay, let's go through question 4 together. So question 4 says the straight line y equals to x minus 1 intersects the curve y equals to x squared minus x at the point A. So I just going to assume that this line intersects this curve at only one point A. Okay, so this will affect how we are going to draw the visualization later. Okay, so find the equation of the line which passes through A and is perpendicular to the line. Okay, so we do it step by step. Let's draw first. So first thing first, maybe the curve looks like this. Okay, then after that, I'm going to draw a straight line that only cuts the curve at one point. So probably something like that. Okay, and then I'm going to label this as A, right? This is what they want at A. Okay, then they say find the equation. Okay, let's label first lah, label the line. So y equals to x minus 1. Then this is y equals to curve, right? So x squared minus x, and then this is A. So find the equation of the line which passes through A and is, so the line, right? Equation of the line must pass through A and is also perpendicular to this line over here, this line. Okay, so that means I need to draw a perpendicular line that cuts through A like that. Okay, and so they are finding this line, and I'm going to label this as L2. Okay, they want this line. All right. So first thing first, first thing first, we need to find A. Okay, we need to find what is coordinate A. So as you can see, right, coordinate A is the intersection of a line and a curve. So it means we are going to do simultaneous equation. Okay, so what we have is y equals to x minus 1, equation 1. Then y equals to x squared minus x, equation 2. Okay, so I'm going to sub 1 into 2. All right, so x minus 1 equals to x squared minus x. So x squared minus 2x plus 1 equals to 0. And then I can factorize it to become this. Okay, and therefore my x is equals to 1. All right, so I have x equals to 1 already. So I need to sub x equals to 1 into equation 1. Right, so y is equals to 1 minus 1 equals to 0. Therefore, my A coordinate is 1, comma 0. All right, so now I can fill in this. Let me write in blue. Okay, so this A is 1, comma 0. Okay, so the next part here, what we are going to do is to find what? The gradient. All right, the gradient of L2. Right, because in order for us to find equation of line, we need what? Gradient and y-intercept, right? So we need these two, mx plus c, right? We need this and we need this, right? Okay, so what do we do? Okay, we got to find out what is gradient of L2 lah, right? So gradient of L1, as you can see, is actually equals to 1. All right, so that means the gradient of L2 is actually negative 1 divided by 1, right? Which is negative 1. So the gradient of L2 is negative 1, right? So that means L2 is y equals to negative x plus c. All right, so now how to find out what is the c? This one. We need to sub A. Okay, A is a known point, right? So we need to sub x equals to 1 and y equals to 0, which means point A, lah, coordinate A, right? Into L2. So we will have 0 equals to negative 1 plus c, and then yeah, so c equals to 1. So therefore, our L2 is actually y equals to negative x plus 1. Okay, so this is the equation of the line that passes through A and is also perpendicular to our line y equals to x minus 1. Okay, okay, let's go through question 6 together. So the coordinate of the point A, B, and C are, all these coordinates here, respectively. I'm a bit lazy. Okay, so part 1. Find in terms of t the gradient of AB and of BC for which t is not equal to a negative 1. So basically, there's nothing else to find, right? Just find gradient of AB and BC in terms of t. So you don't even need to know what is t. Okay, so gradient of AB, right, is equals to, let's see, negative 1 minus negative 3 over negative 2 minus 2t. All right, minus 2t equals to, this is just 2 over negative 2 minus 2t, which you can simplify. Okay, I'll show you how to simplify it. So factorize the 2 from the bottom first. So you have something like that, negative 1 minus t. Then you can just cancel top and bottom. Then you get 1 over negative 1 minus t. Okay, so this is for gradient of AB. Okay, gradient of BC, right? So it's equals to T minus, wait, let me just take a look. Okay, T minus -1 over -1 minus -2, right? So this is just T plus 1 over 1, which is just T plus 1, essentially. Okay, can? And then they are telling us that, T cannot be equals to -1. All right. Okay, so let's move on to 6 part 2. So this is for part 1, right? And then 6 part 2. So they ask us to show that the lines AB and BC are perpendicular for all values of t. So how do we show that they are perpendicular? So we need to prove this relationship. Okay, what is it? We need to show that this gradient of AB times gradient of BC is equals to -1. Okay, so how do we show? Now let's take a look. So that's what I'm going to do. Gradient of AB times gradient of BC. Oh yeah. Anyway, you cannot start by writing this for the question. I'm just explaining, right? So you got to show this equation. I mean, you got to show that this happens, all right? Gradient of AB times gradient of BC gives you -1, but you cannot write it at the start. Okay, so look at what I'm going to write. So gradient AB times gradient BC equals to 1 over -1 minus t multiplied by t plus 1. Okay, this is what I'm going to show. And I'm going to show that it simplifies to become -1. Okay, so basically for this fraction, right, I'm going to factorize out the -1 from the bottom. So 1 over -1 bracket 1 plus t. All right, times t plus 1. All right, which is equals to t plus 1. Now you can multiply them together. So t plus 1 over -1 bracket t plus 1. All right, this one you can cancel, right? So you will just be equal to -1. So then after that, you can conclude since gradient AB, okay, maybe let's write out in words. I'm just going to type it out. So since gradient of AB multiplied by gradient of BC is equal to -1. Therefore, the lines AB and BC are perpendicular, right, for all values of t. Okay, so this is what I'm going to write for my answer. It's just a basic summary of what happens, right? So basically, we prove that, gradient AB times gradient BC gives us -1. So since that, since they give us -1, therefore we can say that these two lines is perpendicular to each other. Okay, so that is it for question 6. Okay, let's do question 7 together. So we have a diagram here, very good. So we don't need to draw, right? So this diagram, right? The point F is the foot of a perpendicular from the point 1,9 to the line y equals to x. So find the coordinate of F. So let's do this. So let A, right? A be the x coordinate of F. Okay, so I'm going to sub x equals to A into the y equals to x line equation. Why? Because F is on the line y equals to x. So when I do that, my y is also equals to A, right? So therefore, I can label F as A, comma A. Okay, so why am I doing this? I want to make sure that, my coordinate, right, has only one unknown, right, which is A. I do not want to have a scenario where we have A, comma B, because usually we will have to deal with simultaneous later on, which I try not to because the equation, the solution will be more lengthy. All right, so I'm not going to do this, right? So I'm just going to find out, X is A, right? So what is my Y in terms of A? So in this case, right, my Y in terms of A is also A. Okay, so I'm just going to label the diagram. So F is A, comma A. All right. So as you can see, this line, okay, this Y equals to X line is perpendicular to this line, right? So let's label this line as L1. All right. So that means I can say that gradient of L1 is actually equals to -1 divided by 1, right? Because this one, the gradient, which is m, is equals to 1, right? So -1 divided by 1 equals to -1. All right. So this is the gradient, okay? The gradient of L1, okay? So that means I also can say that uh, this the gradient formed between this coordinate 1 comma 9 and a comma a is also going to be -1 as well, right? So I can have this gradient equation. So a minus 9 over a minus 1 equals to -1. Okay, you all understand how I get this? So it's a gradient, okay, gradient formed between my coordinate 1 comma 9 and f, which is a comma a. Okay, so that's why I have a minus 9 over a minus 1 equals to -1. So I'm going to cross multiply. Yeah, my 9 looks like a. I'm going to write my 9 properly. So equals to cross multiply, right? So negative a plus 1. So shift, try to find a, right? So 2a equals to 9 plus 1. So 2a equals to 10. So a equals to 5. Right? So therefore, my f coordinate is 5, comma 5. Okay? So this is question 7.